I have some questions here from the test. So let's do this ones slightly different from what we did in our previous class. Here is giving us text 2. Around the center of the circle. Here we have y and w. Here's y and w. Now we have to find the value of the unknown. So in this case, we are looking for y and w. Find y and w. Now, if we want to find the value of y and w in that question, the first thing is we need to recall the theorem which we are going to apply to solve this particular question. The theorem that says angle at the center is twice that subtended at any other point on the circumference. So with that, we get the value of y. Y is at the center. This one is at the circumference. Okay? So we have y equal to 32 times 2. That will give us 64 degrees. Angle at center twice circumference. Now theorem. And check what we did in our previous class. Then this one, this W, and this one, they are in the same word segment. They are in the same segment, or you can say W equal to 32. They are in the same segment. So they're almost in the same segment and what equal. Now, if you don't use that, then we can say that W is equal to y over 2, which is 64 over 2, and that is what 32 degrees. Then, for that particular one, now make use of this particular angle at center. Twice circle. Angle at center. Twice cycle. So whatever the theorem to use, we get what the same answer. That example 1. Let's take a look at another example. Let's see example 2. Sure, this one is clear. If you have any question on this, send it to me via the comment section. If you are watching us on YouTube, please do want to subscribe to our YouTube channel. So you'll be the first to be notified anytime we upload a new one video. Let's take a look at example 2. The center of the circle. as x. Is v. Here's 119. And here is y. So I'm looking for find x, y, and v. Now for this question here, let's take a look at the question again. Look at the diagram now. We need to think about the theorem we are going to use to solve this particular question. The same thing angle at center is twice both circumference. If you look at experience I gave you, under angle at center twice circumference. There was one I gave you like this. There we have something like this here. I said whatever is here, if there's A, then here will be 1, 2, 1, A. So if compare this one now with this one, you will see that this x here and this 1, 9. That will was with angle at what center twice with circumference. So for this one, the value of x can be obtained by multiplying 119 by 2. So we have x so we have x equal to 119 times 2. And that gives us 138 degrees. The 138 or 238 rather, it was 238 degrees. 119. See? 230 degrees. Now the rule is angle at center at the theorem twice angle at center twice circumference. Angle at center twice both circumference. So now that we've obtained that, the next thing is to get the value of y. We get the value of y. X and y, they are the points. So our called angles at a point. Some of angles at a point is 360 degrees. We use that in the part 1 of this series. So angle at a point sum up to 360. So we get x plus y equals 360 degrees. That's angles at a point. Angles at a point. Now x is 238 plus y equals 360. So y will be 360 minus 230 That was what? 122 degrees. Now that we've obtained the value of y, the next thing I want to get is the value of v. V, for us to get v, we look at the value of y as well. Same theorem, angle at center is twice the circumference. Angle at center is twice circumference. So this y is the angle at the center for this one. And this one is going to be twice the value of what v. So I'll get v equal to 122 divided by 2. Okay, that's the value of y. Y over 2. That will be 122 over 2. And now that was 61 degrees. And the theorem is angle at center twice circumference. Angle at center twice the circumference. This thing is not something that is very difficult that you cannot handle. All you need to do is try to remember the theorem. I can only remember the theorem by constant practice. Mathematics is best done or best understood by a constant practice. The more you practice these things, the more you get used to it. Okay, let's take a look at example 3. See, get something a little bit technical now. Okay, let's see this one. We have this here. Come in here. Straight line from here. Center of the circle. That's B. That's center O. Yes, 43. Yes, A. B and C. And they will point towards D. So look for the value of what? A, B, C, and D. Find A, B, C, and what? D. Now, for this particular question here, look at it again to think about the theorem, the best theorem to apply. Think about the best theorem to apply to solve this particular question. To solve this particular question there. Now take a look at this. Yes, what thing? Yes, what A. Okay, there's a theorem. Not under this one, not under this topic, but under angles and lines. Under angles and lines, it says vertically opposite angles are what equal. Vertically opposite angles are equal. So use that theorem to get the value of A. See, in mathematics, a lot of topics are interwoven. So, for you to get better understanding of certain topics, you have to look at some other topics first. Okay? We have a topic, a series of angles and lines, okay, which we are going to upload soon. So watch out for that series. So, from there, we know that what? Vertically opposite angles. We'll talk about vertically opposite angles. We have a straight line. Let's just illustrate that so you understand what we're talking about. I mean, this one is a straight line. You have another straight line like that. Okay? This angle here, this one is A. This angle becomes what? A. This is what's referred to as what? Vertically opposite what angles. So angles facing each other are equal. The same thing, if here is C, here will also be what C. They are vertically what opposite what angles. So vertically opposite angles are what equal. Okay? So now that you've learned this, let's proceed now. Let's see. So from here, angle A is vertically opposite to this 40/3. So A can have A equal to what? 43 degrees. They are vertically opposite. They are vertically opposite what angles. So now that I've obtained the value of A, if you look at that diagram, O is the center of the circle. Since O is the center of the circle, from the center here, so the circumference, he said that the distance from the center here, so the circumference. Now from the center of the circle to the circumference is called what? The radius of the circle. That's the radius of the circle. So that means this distance here is equal to what? This distance here. Now, under triangles, there's what's called isosceles triangles. In an isosceles triangle, the base angles are equal. The base angles are equal. The opposite sides are equal, the base angles are equal. So you have a triangle like this. You have this symbol here. It means that this one is an isosceles triangle. So these two sides are equal. So this angle will be equal to what this. So this angle Y, this also will be what? Angle Y. So now that you learned that, let's look at this. This is A, so that means C and A are going to be the base angle of this isosceles triangle. So from there, I'll get C equal to what? A, and that will be what? 43 degrees. That's base angles of isosceles triangle. These angles of isosceles triangle. The base angles of isosceles triangle are what? Equal. So now, the next thing I will do is to get the value of what B. So look at this one now. We have what? A triangle. We have a triangle here. Here's A. Here's B. Okay, here's C now. And here's what B. So that's the complete triangle. The sum of angles in a triangle is 180 degrees. Since I know that this is a triangle, what it means is A plus C plus B equals what? 180 degrees. The sum of angles in a triangle. Sum of angles in a triangle is what? 180. So we have 43 plus 43 plus B equal to what? 180. So this will give us 86 plus B equals 180. Get the value of B as 180 minus 80 was 6. And now it was what? 94 degrees. 94 degrees. The next thing I will do now is to get the value of what D. Now come back to what the circle what geometry. We come back to the circle what geometry. So now this one becomes what? The angle at the center. Angle at the center. And then we know that what? Angle at center is twice what? Circumference. Angle at center is twice what? Circumference. Now D will now be B all over 2. That will be 94 all over 2. And that will give us 47 degrees. And the theorem for that is angle at center twice circumference. Angle at center twice circumference. So I'll show you how to break this thing down to get all the given, all you know in this particular question. It is not something difficult, like I say, it's just for you to understand the basic theorems. You understand the basic theorems, you can actually handle most of this question, most of this mathematics. Okay? If you are enjoying this lecture, please hit the subscribe button to subscribe to our YouTube channel so that you'll be notified whenever I upload new series. Let's take a look at example 4. Okay. This. Here's V. Here is W. Here is what? U. So I'm looking for the value of phi T U V W. Mind you, you can calculate any one first. So the one that comes to your mind first is the first one you should calculate. Let's take a look at that figure now. It doesn't matter how complicated the figure is. It's just for us to break it down and see if we can find the required theorem to solve that particular question. Now let's take a look at this one now. For us to get the value of t, which is the first thing I'm going to get in this question, you see that this one is a triangle. That's a triangle. And for what we just did in the previous example 3, is example 4 now. So the sum of angles in a triangle is what? 181 degrees. Since I know that the sum of angles in a triangle is 180 degrees, I can get the value of what t. So now let's do that first. For this triangle here, we get plus 81 plus 53 equals 181 degrees. The sum of angles in a triangle is 181 degrees. So let's see plus. Okay, let's do that first. Plus t plus 134, 180 degrees. So sum of angles in a triangle. Sum of angles in a triangle is what? 180. So the next thing I will do is to collect the like terms. Transfer 134 across what? The equality. So I get t equal to 180 minus 134. That gives us what? 46 degrees. That is the value of t. T is what? 46. T is what? 46 degrees. The next thing I will do is to find a way to get the value of the value of W and the value of what? If you have watched the previous lecture where I gave you the theorems, then you know that there's a theorem that says the opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. So this C and this U, I'll get C plus U equals what? 180 degrees. And just write opposite angles of cyclic quadrilateral. Let's abbreviate that. Opposite angles of cyclic quadrilateral are supplementary. And is the sum of the 180. So T is 46. So I'll get 46 plus U equals 180. So U will now be 180 minus 46. That equals what? 134 degrees. So now that I've obtained the value of U as 134 degrees, the next thing I will need to get is the value of V and the value of W. If you look at that diagram very well, you see that there's a symbol here and here. What it means is that this side here, the lengths here and the lengths here are what? Equal. And since they are equal, it means that this particular triangle here is an isosceles triangle. And from what we did in example 3, I said the base angles of isosceles triangle, they are what? Equal. That means V is equal to what? W. V is equal to W. So I'll get V equal to W. That's base angles of isosceles triangle. Base angles of isosceles triangle, they are what? Equal. So now, since V is equal to W, I can get V plus W plus U equals 180 degrees. The sum of angles in the triangle. Sum of angles in the triangle is equal to 180. And since V is equal to W, I can say V plus V plus the value of W. Sorry, not W now, U, the value of U. U is 131.4. Value was 180. So I get 2V plus 134 equals 180. So that 2V will now be 180 minus 134. 2V. We subtract now the left of 4 towards 6. So the next thing that we need is to get the value of V by dividing both sides by 2. So V will be 46 over 2. And that was what? 23 degrees. So W equal to V. And that will also be what? 23 degrees. It is not something difficult like I always told you. Just try to remember the theorems. If you can remember the theorems, then you can actually solve any question on the circle geometry. If you have any question on this, what I've done so far, send it to me through the comment section. And please comment whenever you watch our videos. It helps you to know that you actually understood what you have watched. And please ensure you subscribe to our YouTube channel. If you find this video educational or you find it interesting, it will help us to know that you are actually following our series. Let's take a look at example 5. Let's see another example to give you a better understanding of what we are doing under this circle theorem. Example 5. So it's kind of tricky. Try as much as possible. Break it down so that you understand what I want to do. Straight line here. Here is 90 degrees. Here's 21. Here's W. Here's the center O. Here's Y. Here's M. And here's X. This is Z. We have 21. W. 90. We have Y. We have X. And we have M. Okay, let's see how we get the value of this unknown in this particular question. We're looking for W. We're looking for Y. We're looking for X. We're looking for M. Okay. The question, the diagram, it's a little bit complicated now, but it's just for us to find a way to break it down. Now break it down, then you can actually get the answers. Okay, let's start with W. Because of this symbol here, there is a triangle. We have this triangle here. Here's 21. Here's W. The symbol there represents what? 91 degrees. So what I have is W plus 21 plus 90 equals what? 180 degrees. That is sum of angles in a triangle. So that W will now be 180 minus 21 minus 90. When you do this one, you get the value of W as what 60 degrees. Now that I've obtained the value of W, we'll take a look at the figure again. Let's find the next thing we can actually get from this figure. Now, this is the center of the circle. This is the center. Then there's a theorem that says angle subtended at the center of the circle is twice that subtended at any other point on the circumference. Okay, let's see. I gave you a diagram like this before. Angle at center twice circumference. I gave you two diagrams for that one. Okay, so that if there is A, here is the center of the circle, here is going to be double, that's 2A. Now to compare that diagram with this one here, if I remove this line now, and this one, I'll have this one, in the center, corresponding to this for that particular figure. So X is going to be double of what? W. X is going to be double of W. So we can have X equal to 2W. S equal to 2W. That is angle at center twice circumference. So abbreviate that. Circumference. So angle at center twice with circumference. So now X will now be 2 times 160 9. When you multiply that, we get 138 degrees. That gives us 138 degrees. So after obtaining that now, we take a look at the diagram again. Take a look at the diagram. You see something glaring there, which is Y. X and Y, they are the points. X and Y are the points. I would say sum of angles at the point is what? 360 degrees. So I raise this one now. Small angles at the point is what? 360 degrees. So then X plus Y equal to 360 degrees. the sum of angles at a point. Sum of angles at the point sum up to what? 360 degrees. So now that I know that one, the next thing I will do now is to substitute the value of x, which is 138 plus y, that will be 360. To get the value of y, I subtract 138 from what? 360. That will give us what? 222 degrees. So now that I've obtained the value of y, what is left is the value of n, which I'm sure, looking at that question now, you know how to obtain the value of n. So there's another theorem again. Angle at center is twice the circumference. So y is for the center, n is for the circumference. So I'll get n equals y over 2. And that is 422 over 2. That is 111 degrees. And the theorem is angle at center twice circumference. Angle at center twice circumference. So like I said, it's not a difficult thing to do. No matter how the diagram looks like, all we need to do is to find a way to break it down, just like I did for this particular question now. To do that, you get a better understanding, and you know the exact theorem to use to solve the question. We're going to stop this class here. In our next class, I'm going to look at some more examples on circle geometry. That's going to be part 3 of this word series. Until I come your way again, I remain your host, Godwin Ariel. Have a lovely day ahead.